All right, today we're going to be looking at direct and inverse variation. The front of our notes are going to be on direct. Direct variation is always in the form y is equal to kx. And k is actually the same thing as our slope for direct variation. To find k, we need to take y and divide it by x. And that's going to be the two things that we need to remember is our equation and how we find k. Our y-intercept is always 0. That's why we don't have a b there on our equation. Some examples, y is equal to 2x. That would be an example. It's just a number times x, a slope and x. Or y is equal to negative 1/2 x. That's also a direct variation. It can be negative and it can be a fraction. Graphically, it's always a straight line that goes through the origin. So some examples of a graph going through the origin, straight. Does need to be diagonal though. Can't be horizontal or vertical. It can be positive or negative. It's going to be going uphill or down. We're going to look at some examples of direct variation. One is from a table. If I'm trying to determine if something is direct variation from a table or even a set of ordered pairs, first thing I want to do is verify that k is constant. What does that mean? That means it's the same. Has to be the same. How do I do that? Well, up above we said k is always equal to y divided by x. So we verify that first. So step 1, check in on my k. 3 divided by 1 gives me 3. 6 divided by 2 gives me 3. 9 divided by 3 gives me 3. 12 divided by 4 gives me 3. So right there, if I didn't know this was direct variation, I could check it by what I just did. I take y and divide it by x. So this is x, this was y. And I took y and I divided it by x for every ordered pair, every time. And then if it was the same thing, I know it's direct variation. Step 2 is then to write the equation, because typically with direct variation problems, they're going to ask you to write the equation. So how do I write the equation? This is step 2. I think about what the equation is. Y is equal to k times x. But now I know I did all this work over here, all that work to find out what the constant was, so I'm going to write that in there. It's not just k. We know what the constant is. It's 3. So that is step 2. That's our equation. Example 2. It says each point on the graph, well, there's only one graph, not graphs, is on a line from a direct variation, from an equation that's direct variation. So something we know from up top when we talked about graphs, if you look back on the top of the notes, we said that direct variation always goes through the origin. So we know that's a point. Always. If I see that word direct, I know it's going through that origin. So that's 1 point right away. That's a freebie. Now that I have 2 points, we know how to calculate slope from 2 points. And I can see that I'm going up 1 over 1. So I do the same thing, up 1 over 1. And then that gives me my next point, which in this case is 2, 2. Problem said to find 3 points, so I need to do that again. Go up 1 over 1. There's my next point, 3, 3. Those aren't the only points, and if you had other ones, that's fine. You could keep going on. You could do 4, 4, or you may have went the other way. You may have gone down 1 and back. You got the point negative 1, negative 1. In fact, we could write this equation even though it's not asked, because we know our k. Y is equal to kx is our equation for direct, but we know we went up 1 over 1, so that makes our slope 1, or y is equal to x in this case. That should say example 3. So in example 3, this one says, given that x and y vary directly, right there they're giving me some hints. I know, I'm already thinking y is equal to k times x. And I'm thinking, to find k, I do y divided by x. Even before I've read the rest of the problem. It says, and x is equal to negative 3 when y is negative 30. Write the equation. That's one thing I have to do. And then I have to use that equation to solve another problem. So step 1 and 2 here have to do with the equation. How do I write the equation? Step number 1, find k. I already know over here, I wrote that formula. That's how I find k, so I can do the work for that. K is equal to, they gave me some information right here, negative 30 divided by negative 3, which is 10. So there's my k. Step 2 is to write your equation. So it's all there are 2 steps to write the equation. So my equation, y is equal to kx. See, I wrote that over there, so I remembered. But I know what k is now, because I just figured that out. K is 10. So there, I've answered half the problem right there. I wrote the equation. Part 2 is to solve the problem. So I'm going to use that equation, y is equal to 10x. I'm going to plug in what I know for x. So y is equal to 10 times a negative 8, which means y is equal to a negative 8. That's the second part. All right, the next example is a real-world example. So let's read through that one. It says, over spring break, Daniel began working on a painting crew with his uncle. On Saturday, he worked 7 hours and got paid $56. So he had hours of 7, pay of 56. I'm just going to write that down so I don't have to go back and read through that. Pay is directly related to the number of hours worked. Well, we see that word direct, but it's relating pay and number of hours. So if we think of our direct variation, it's y is equal to kx. But in this case, we want to replace those variables. We want to replace y and x with these variables, pay and hours. So pay is directly related to the hours worked. So that is the formula we're going to use for our problem. Now it says to set up an equation. So this is our equation, but we need to know what k is. And if you recall from the other problems, we know that to find k, you do y divided by x. Well, in this case, we're using different variables. So in our equation, p is in the y position, so it's p divided by h. So that's what we'll do over here. We'll find our k by taking p and dividing it by h, which is 56 divided by 7, or 8. So our equation is p is equal to 8h. So that was part of the problem. Then it says set up an equation, which we did, then determine how much he would make if he works 30 hours over the course of a week. So our h here is 30. So we're taking our equation. P is equal to 8 times h, but we have a new h of 30. So our P is going to be $240. That's how we would do this direct variation in the real world. On the back is our inverse variation. Inverse variation is the inverse of direct. So instead of it being y is equal to k times x, it's y is equal to k divided by x. To find k, we do x times y. K is our constant of variation, but it is not the slope. We have no intercepts here. We're not crossing the x or the y-axis. So some examples, y is equal to 2 over x. So you could have a positive number divided by x, or you you'd have y is equal to negative 3 over x. So it could be a negative number divided by x, but it's always x is the denominator. This graph is not a line. It's actually two curves. And it does not pass through any of the axes. So an example, if we have a positive k, so like y is equal to 2x if it's positive, we would have a curve in quadrant 1 and a curve in quadrant 3. If we have a negative k, like y is equal to a negative 2 over x, we would be graphed in quadrants 2 and 4. So always curve, two curves in opposite quadrants. So again, from a table, similar to with direct, you're going to verify that k is constant. And in this case, we're looking for x times y being the same. So we'll do that. We're checking to see if this is the same. 3 times 8 is 24. 6 times 4 is 24. 12 times 2 is 24. 24 times 1 is 24. So when we multiplied our x and our y, we got the same thing, and that's our k. If we multiply, it's inverse. If we multiply and it's the same k, it's inverse. If we divide and it's the same, then it's direct. Then we need to write our equation. So our equation is y is equal to k over x. But instead of us putting k, because k is just the generic form, we're actually going to put what k is for our situation, which is 24. There's our equation. Example 2. Given that x and y vary inversely, so I'm already thinking inverse, k over x, and then to find k, I do x times y. When x is 4 and y is 20, write the equation that relates x and y, and then we're going to use that equation to generate another ordered pair. So step 1 and 2, remember that this is for writing the equation, which is only half of our problem. So step 1 is to find your k, or determine your k. In this case, we know that k is x times y, and we were told that we have an x of 4 and a y of 20, so our k is 80. Step number 2 is to write the equation. So we know that with inverse, it's k over x, but we know what our k is in this case. Our k is 80, so it's 80 over x. That's our equation. And that's part of the problem. Now, the second part of this problem. So we answered that part. Now we got to go to this. Using that equation, find the value of y when x is 10. So, y is equal to 80 over x. But we know that x is 10 in this case. So what do we get when we plug a 10 in for x? We get 8 for y. So that would be our y. Y is equal to 8. Another real-world problem, but this time with inverse. It says Daniel did such a good job painting over spring break that he has been contracted to paint his neighbor's house. The neighbor said that he would pay him $1,000 to paint the whole house, and he can use as many painters as he wants. Pay is inversely related to the number of painters. So, just like we did with direct, we know that inverse has this equation, but we have different variables. So we have pay is inversely related to the number of painters. I'm just going to let n be our number of painters. It says write an equation to represent the number of painters n, which is what they used to, and the pay each will receive, which is p. So all we have to do on this one is write the equation we know that our pay is 1,000. That's what he gets total. And that the K, oh, actually in this case, thinking about this one, we're given our K. No matter what, let's rephrase that. This is our K right here. We're given our K because no matter how many people he hires, he's getting paid $1,000. So that's a constant. Sometimes you got to reread that. I almost made a mistake. That's our constant. No matter how many people he hires, he gets $1,000, but he's going to pay the people he hires. So each person's pay, and that's what it said, what will each person receive, is equal to $1,000 divided by the number of painters. So that's our equation. We just took this equation, changed it into the words that we were using, pay and number of painters, and plugged in what we knew, which was our K. All right, you can work on the you-dos next.